Constructors and destructors are special member functions that serve a particular purpose. There are several types of constructors in C++ and one type of destructor. Let's take a look at class.cpp for an example. We'll copy this and paste it into our working project and open it up in the editor. Just going to maximize it so you can see it here. Here's our very simple class, and you'll notice that among other things, it has no constructors or destructors defined. And so C++, in a case like this where you don't provide any constructors or destructors, it implicitly provides a default constructor, which is a constructor that takes no arguments. And you'll notice the way this is constructed in line 15, there are no arguments. And so the default constructor is the one that's being called, and that's the implicit default constructor that's provided by C++. There's also a copy constructor provided, and a copy operator provided, and a destructor provided. So let's go ahead and run this for a second here. We'll push the compile and run button, and you see that value is 47, and that happens on line 18 where the value is printed. Go ahead and make a copy of that line 18, and I'm going to paste it in before the set value line. And so now it looks like this. I'm going to save and compile and run. And you'll notice that the implicit default constructor has actually set the value of our private data member to 0. And what the implicit default constructor does is it actually calls the default constructor on any of the data members in the class. And so in this case, we had 1, it's an int, and the default constructor on an int sets its value to 0. So that's the implicit constructors and destructors. Let's go ahead and close this, and we're going to delete our class.cpp from our working project there and run clean. And now we're going to really get into this. Let's make a copy of constructors.cpp, and I'm going to paste that into working here. And we're going to maximize that so we can see it. I'm just going to page through it real quick. It's a bit long for the folks who are typing along at home. I'm just going to point out a few things here to start. You'll notice we have our class animal, and you notice it has a number of constructors and a destructor defined, and it even has a copy operator defined. And we're going to get into all of that in a moment. And then you'll notice the implementation section here, where we have actually provided the implementation for all of these member functions. And there's our operator overload. And then down at the bottom there's a main function which constructs a number of different versions of this, and it constructs them in different ways. So a constructor looks like this. Let's take a look at our default constructor on line 13. The default constructor has no arguments, and so it's the name of the class. When the name of the class is the name of the function, that means it's a constructor. So constructors are just the name of the class as the function name, and then whatever arguments and whatever implementation you have. So in this case, we have a default constructor because it has no arguments. So line 13 is the default constructor. Line 14 is the constructor with arguments. And you'll notice that this constructor has 3 arguments, and they're all strings. Line 16 has what's called a copy constructor because this constructor has as its single argument another object of the same type. Line 17 is our copy operator, and this is an operator overload. It returns a reference to the object itself, and it takes as its parameter a reference to an object of the same type. Line 18 is the destructor, and the destructor is indicated by a tilde in front of the function name, and then the function name after the tilde is exactly the same as the object or the constructor. And finally, we have a print method that we're going to use for printing out these objects. So let's take a look at the implementation for the default constructor on line 22. So this is a syntax that you probably haven't seen before. You notice we have this colon, and then after the colon, we have these things that look like constructors or function calls before the opening curly brace. This is what's called a constructor initializer list. So the colon sets it apart, and then you can actually initialize your data members without ever actually getting into the body of the function. And whatever's here is actually executed before the body of the function. So you may actually not even have a body of a function. In this case, we only have a body so that we can print out this string. So the way these initializers work is you have the name of the object that's being initialized. In this case, it's that string type. And then in parentheses, you have whatever value you're going to be initializing it as. This is actually the same syntax as if you were going to call a constructor on an object. If we come down here into the body of our main, you'll see that we construct this B object, which is of type const animal, and we construct it with parentheses and then parameters inside the parentheses. And so this same syntax is what's used in the constructor initializer list. And so they're separated by commas, and you can initialize whatever you want up there. And then in the body of the function, we just have this cout, and the purpose of that is so that as we call each of these constructors, we have an idea of what's happening, and we can kind of follow the flow. It's really just for educational purposes. You wouldn't put that in an actual constructor. So moving along in line 26, we have the constructor with arguments. And here we have the arguments list. We have type, name, and sound, and these are strings, and we're simply initializing in our initializer list those corresponding variables in our data members. We have the copy constructor starting at line 31. This takes a reference to an animal object as its argument. We print out a string that says this is the copy constructor, and then we do the assignments. We assign the data members from the object being copied to the data members in our own object. And you'll notice here on line 35, we're prefixing this clone prefix. This is from our constants up on lines 5 and 6. The unknown constant on line 5 is being used in our initializations on line 22, and the clone prefix constant is being used in our copy constructor down there on line 35. Then we have our destructor, and again, we just have a string that says we're calling the destructor. There isn't really anything for the destructor to do here. We have our print function down on line 44, which simply prints out the name, the type, and the sound of the animal. And then on line 49, we are actually overloading the assignment operator. And the reason that we're doing this, it's something called the rule of threes. And this is a C++ thing you might hear it referred to now and then. The rule of three says that if you find yourself needing to overload any of the implicit methods that C++ normally provides, the copy constructor, the destructor, or the copy operator, if you find yourself needing to overload any one of those, you should probably think about overloading all three. And in fact, especially because we're overloading the copy constructor, we want to overload the assignment operator so that you can see the distinction. You can see when we run it, the difference between what happens on line 66 and what happens on line 69. Line 66 is a copy constructor and line 69 is an assignment operator. So we'll be able to see what happens there. So let's go ahead and run our code. I'm going to press the big green compile and run button here. And here we have what goes on. Now we're going to come down here into main and we'll see what happens. In line 60, we construct an object with a default constructor. And that's because it has no arguments. It's just animal A like that. And so we'll notice our default constructor up here on line 22. It simply initializes our three variables with the unknown constant string. And there's our unknown constant string up there, has the word unknown in it on line 5. And so our default constructor, and then we call print, and we see it prints out unknown, the unknown says unknown. So that's exactly what we expect to have happen with our default constructor. Next, we call the constructor with arguments, with goat, bob, and bah. And so we get the string constructor with arguments, so we know that we're calling the right constructor, and the print prints out Bob the goat says bah. Then we call our copy constructor on line 66, and we see that we get the string copy constructor on our console. And then it says clone Bob, the goat says bah, because our copy constructor is copying object B as it constructs object C. And so our copy constructor, you'll remember here, let's go up and take a look at our copy constructor. On line 35, it copies the name, but it prefixes that clone prefix. And clone prefix, again, is up there on line 6, and it says clone dash. And so we get clone dash Bob, the goat says bah. Then just to see the difference, on line 69, we have the assignment operator. We're assigning the value from C, which remember says clone Bob, the goat says bah. We're copying that object into A using the assignment operator. And so if we look up at our assignment operator, right there, we see on line 53, it copies name with the clone prefix again. And so when we print it out on line 70, we get clone Bob, the goat says bah. That's this one right here. Now we're at the end of our function, and all of the destructors get called because all of these objects go out of scope, and so they all get automatically destructed, and they get destructed in reverse order. So the first one to get destructed is C. And remember, C says clone Bob the goat. Then B gets destructed, which is just Bob the goat because it doesn't have any copy operations involved in it. And then A gets destructed. And remember, A was assigned with the assignment operator, and it got a copy of C, and it got clone Bob the goat. And so that's our last destructor there. So there's just one more thing that we need to cover here, and I'm going to maximize this so that we can see this. You'll remember that C++ provides implicit constructors. And for example, the default constructor here, which I've highlighted here on line 13, if I don't define one, C++ provides an implicit one. If I want the object to disallow the default constructor, in other words, coming down here into main, and the way that I've constructed the A object on line 60, if I want that to be illegal, if I want that to be disallowed, if that's not a valid use case for my class, I can do that by simply taking this default constructor, and instead of declaring it there in public, if I declare it in private, now it cannot be called. And if I do that, of course, I need to get rid of this because I have no implementation for it, and I need to provide it with an empty set of curly braces. So now I have a default constructor. I've defined my own default constructor. I've overloaded the one that's provided implicitly, but it's in private, so it cannot be called. It cannot be seen from the outside. So if I try to compile this, I'll get an error, and we'll need to go back out. We'll need to minimize this so we can see the errors here. But the error says animal is private. And so that simply disallows. It makes it so that if I try to do this, I get an error in my compilation and I realize, oh, I need to actually give that some parameters. So you can overload your implicit constructors in the private section to disallow them. This was a lot, but it's important to understand the constructors. Constructors and destructors are important parts of any C++ class. It's always worth thinking carefully about how your objects are constructed and crafting constructors and destructors that handle all the necessary use cases. So let's go ahead and delete the working file and run clean to get set up for the next lesson.